Hi there, and welcome to IV Tutor. We are looking at regular expressions today with regard to exam preparations. So regular expressions aren't very difficult. You just have to practice them. They are, in general, not easy, but the scope that we go to in this course, they don't really get very complicated. They don't get complicated, actually, if I should say. They stay very easy. It's something you should be able to do off your head. So that's how easy they keep them. Otherwise, regular expressions can get really complicated. And I think if you're watching this video, it means you may have done regular expressions as part of your assignments. And today we just want to do a quick run of regular expressions again and look at a few exam type questions on regular expressions and how you can answer those. And again, there's a handout with all the answers for these questions that you can just go and download and go through. But at least let's do this together so that you can understand how to explain or how to answer these questions or how we get to those answers, right? So when it comes to regular expressions, there are characters or meta characters that are used to match text, and we normally use regular expressions to do text matching or validation. So there are two contexts for using regular validation, regex validation in this course, right? So it's either we are doing matching or we are doing validation. But regardless, the way you build the regular expressions is exactly the same. So let's look at basically the most common meta characters that you're going to be using. The first thing I want you to understand is the usage of square brackets and how the matching works in general. So with regular expressions, a square bracket is used to match a single character. And sometimes you can do without square brackets, right? There are cases where you can match without a square bracket, but I'll just use a square bracket here as the basis for matching, because in most cases we do use them. But you can still not use a square bracket depending on what you're doing. But every single character that you use or identifier matches only a single character, right? So you are matching one character at a time. So if you say A, B, C, for instance, in square brackets, you are saying, I want to match A or B or C. So if I put a word here that is A, B, C, and then in my regular expression looks like this, I am not going to match the word A, B, C. I'm going to match A or B or C. So this will result in 3 matches, not one match is A, B, C. So it's crucial to understand that this is matching only a single character. So here you get 3 matches. It's different from providing a regular expression that is just A, B, C outside square brackets, because this means match A, B, C, the text A, B, C in this sequence as it is. But in square brackets, a square bracket is only matching one character, okay? One character. So what happens then if I want to match the word A, B, C in square brackets? Well, in that case, you may have to specify that do this 3 times using repetition, as we discussed just now. But anyway, you can also use a range. You can also, like this, like 0 to 9, A to Z. It's case sensitive, so lowercase and uppercase are matched differently, or you can even use a combination of everything that you want to match. So this square bracket here, we will go and match a lowercase or uppercase alphabetic character or a number, but just one. Then inside square brackets, you can use this hat here to represent not, which means this means not A or B or C. So not means not everything after the hat, okay? Not everything after the hat, which means it will not match A, it will not match B, it will not match C. And it's got a different meaning somewhere else, as we'll see. But if it's inside a square bracket, it means not, like the exclamation if you were using an if statement. A dot is used to match any character, but just one, any character. W means alphanumeric plus underscore. So any alphabetic character or any number including the underscore. And lowercase s means any white space character. And it's a convention that the uppercase matches the opposite of the lowercase. So if lowercase w here matches alphanumeric, it means the uppercase version of w matches non-alphanumeric, including the underscore, right? So that is what the convention is. If lowercase d means any digit, then uppercase b means non-digit, right? So lowercase d, any digit, uppercase d, non-digit. And these, you have to use a backslash. Because if you just put d, this will match the character d. So if you want a digit, you have to go backslash. Then this means any digit. Now, when it comes to repetition, that is where you then use these ones here. Plus means one or more, and asterisk means 0 or more. And the question mark can be used for something else, depending on what you're doing. It can be used to define what is called the laziness or the greediness of a regular expression. But for the purposes of our studies, we are going to restrict the question mark to an optional group, okay? The pipe is used for or, and normally you use this together with brackets. So you can use brackets to create what are called matching groups or capturing groups, but you can also use brackets just to group your matches together, to group your matches. Like if I want to use or, it's easier if I use that within brackets. So I can say A or B, but you can still do that without using brackets. But in most cases, if we have to use the or, it's wiser to include brackets so that you can demarcate what's constituting your pipe, the two sides of or, right? We also have curly brackets, talking of repetition, that you can also use to repeat something. So if you say curly brackets 3, it means exactly 3 times. So if I go digit 3, it means exactly 3 digits. Or you can specify the lower and the upper bound. So this means at least 3 and at most 4, which means 3 to 5. 3 to 5. You can specify a range rather this way by specifying the lower bound and the upper bound of your curly bracket. So this will match any digits, 3 digits to 5 digits. This will match. If you don't specify the lower bound and you only specify the upper bound, then it means you are specifying the maximum number of allowed repetitions. It means at most 5. And if you specify the lower bound only, you're simply saying at least 3 times going forward. So this will match at least 3 digits and so on. Now, the note here, that the hat that we saw before in this context has a different meaning. It can be used to indicate starts with, where you want your regular expression to start with a certain character or to start with exactly something. And it's mostly used with a $sign, which means ends with. So if you then if you surround your regular expression with these two, you use that for an exact match, where you are saying it must be exactly this regular expression, especially in text matching, where I want a digit and then I can say A, B, 1, 2, 3, 4, C, D. And then you say, no, I want only digits. So in this case, it means it must start with and ends with a digit, which means this would then not match because it doesn't start with a digit, neither does it end with a digit, because the digits are only in between. But if we don't have the starts and ends with characters, that means it will only go and match the digits and ignore the parts that are not digits. So it will just go and match this part. So that is what you use the starts and ends with characters, usually for an exact match. And they normally work more or less the same as the word boundary, but you are using it to govern the boundary of the word, which means if I have a regular expression that says M followed by any character repeated 0 or more times, this can match anything like A, B, M, 3, X, right? But if I put a word boundary here, it won't match because what I want to match is in between the word. So this would then not match. So the word boundary says exactly what it says. It gives you, it says it's a word. It must match it as a word. And then lastly, capturing groups, which are used for grouping matches together. We don't normally use them for our studies for capturing any groups. We've done it. I remember one time we did it but it was during an assignment, but they hardly give you or require you to use capturing groups in exams because it would be complicated to do that off your head. So you can use brackets, but mostly just for the purposes of grouping your matches together or for the purposes of logically arranging your matches together, okay? So that it makes sense. Otherwise, these are the basics. These are the basic meta characters that you use for regular expressions. If there's anything we left out, we can explain it as we go. But having said this, let's look at a few exam type questions on regular expressions. And obviously, if you have done your assignments, I would guess that you have practiced. And one of the websites I normally prefer to use for practicing regular expression is regex101.com. It's a very good website for testing, practicing. It's got a few notes as well. So you can go and look at it if you want to practice and if you didn't know about it until this point of the semester and you're now preparing for exams. So let's look at a few exam type questions on regular expression. This one says, consider the following two regular expressions. Provide any two strings, one per regular expression, which will be matched exactly by these regular expressions. So we know that a square bracket matches only one character. So this one is saying any vowel, uppercase. But then we've got repetition. So it means exactly two vowels, uppercase. So you can provide any two vowels. You can go A, E, or you can go B or U. Any two vowels will do. Not in any order. Even if you go EU, it would still match because that is what your regular expression is telling you there. The second one, you can see it as a not character there, which means not what we are seeing in this square bracket, but repeated one or more times. So in other words, we don't want any uppercase letter from G to Z or any number, but at least one or more. So whatever you give us, one or more, it must not be an uppercase character between G and Z, and it must not be a number. So then I can go, well, A, I can go B, I can go C, F, D, or any lowercase characters will do, any uppercase as long as it's not between G and Z will do. So there are endless strings you can create out of this, right? That's question 3.1. This one says, consider the following three regular expressions. Provide any three strings, one per regular expression, which satisfy the expressions, right? Oh, sorry, here they said one per regular expression, so you were only required to provide one. I thought they said two. Okay, so one would have done. So in this, on this question, I want to clarify something here that might have been a source of confusion. You know that if your regular expression looks like this, then you go, right? And now you want to write this in your program in Qt. You cannot, as a string, you don't have to leave it like this. Now, if you want this as a string, you have to go and escape this backslash. Otherwise, Qt will try and read your backslash S as a special character. So for your regular expression to eventually look like this, it means as a string, you have to write it like this. And then you can do your, so as a string, it then looks like that with the backslash here escaped. No, that's not, I'm not quite sure for this question whether we were looking at this as an escaped backslash, like in the event that you are writing this as a string, or the actual regular expression is actually like this. But I'll explain for both cases, right? Because I'm not quite sure in this case what the intention was, right? So if we are treating this as the actual regular expression, then that means in regular expressions, backslash S means a space, right? Now, if you go backslash, in your regular expression, if you want to match a backslash, you cannot put a backslash because it's a special character. You would have to escape it. So then this means you are saying not a backslash and not lowercase s, but exactly 4 times. So if this is the actual regular expression, then it means as long as what you're trying to make is not a backslash, and as long as it's not lowercase s, then that's fine. So I can go A, B, C, D, and that's fine. But if we say that no, the intention is to actually that escaped backslash that we see is because we are using it as a string in Qt, then it means our actual regular expression looks like this, right? And in this case, we are saying not a space repeated 4 times, in which case your answer is too easy. I can still go with A, B, C, D. So in both cases, you could just get the answer right, regardless of what exactly they meant. But it's important to understand the meaning of, or the differences between the two in terms of explanation, okay? Then in this case, we've got 0 to 9 and any alphabetic character, at least 2 times and at most 5 times. So any number or uppercase or lowercase alphabetic character repeated at least 2 to 5 times. So in this case, I can go with 0, 1, 2. If I want to go with only numbers, I can go with A, B, C, D, E, don't exceed 5. That's it. Or you can go with lowercase A, B, C if you want to go 4, or D. I mean, if you want to do A, B would just do. I mean, it's at least 2, and so on and so on. So there are so many variations of these strings you can provide. And then let's look at this one, which is quite interesting. Dot means any character. So providing 2 dots means, and that is where it's crucial. Remember, a meta character only matches 1 character. So this should match 1 character here, another character here, another character here, and another character here, which means this regular expression matches exactly 4 characters. If we didn't have these 4 here, this was only going to match 1 character. If we didn't have these repetition curly brackets here, this would have just matched 1 character. And in this case, we don't have any repetition going on afterwards, which means this is matching only 4 characters. So what's happening there is the dot means any character, right? The dot means any character. The other dot, any character. This one means you can now match anything between 0 to 9, then A to F uppercase, or A to F lowercase. Anything he'll do, and any other character, which means for your answer, put anything you want. 4, anything you want, X. But here must be a number or any A to F alphabetic character. So I can go with another number, or I can go F and then any character, Y. So that is how these then, so this matches there, this one there, this curly bracket there, and this Y goes there. That is how you can then provide a string that matches here. So that is how you can provide a string for that regular expression. This one says the last 3, what is this doing here? So, okay, I don't want this part of the question. Sorry, I don't want this part of the question. We only want, no, we do want that part. Okay, I'm thinking about something else. List 3 ways in which the Qt framework supports validation of user input using validators. Okay, so there are 3 types of validators that you can use, right? And I'm not sure if that is what they wanted, or they wanted just 3 ways, because using validators, there are 3 validators you can use. So if they wanted 3 validators, maybe they would have said just use 3 validators, list the 3 validators that you can use, because in that case, you can use a Q int validator, I think. You've got a Q double validator and validator. And you've got a Q regular expression validator. Regular expression validator. So these are the three validators that you use in the Qt framework when it comes to validating input. And this one is used for integers, this one is used for decimal point numbers, and this one is used when you want to use a regular expression to validate something. But regardless of which validator you want to use, you can use a validator in one of the following ways, right? Number one, you can use the set validate function, on a line edit in order to set. So what you do is you create a validator which can be any one of these. So you make an instance of any of these three validators, and then you use the set validate function on the line edit to set that validator as the validator for your line edit. And that will restrict the user from typing in any input which does not conform to your validator or to your regular expression or to your validator, depending on which one you are using. The other option that you can also use here is you can use the validate function, using the validate function of your validator. So in this case, you do the validation manually, right? So you create an instance of your validator, and then you grab your input somewhere else, then you call the validate function of your validator. And this will then give you one of three responses. Is it acceptable? Is it invalid? Or it's so there's acceptable. It can say it's intermediate, which means it's a plausible input, intermediate, or it can say it's invalid, which means it does not match at all, right? Using the validate function. The third way is you can you can inherit from the existing validator and implement your own validator. But I think that may not be taken as a way of supporting validation, but simply, you can inherit or implement your own validator. Implement your own validator by inheriting from Q validator. So those are the three things I can sort of think about when it comes to using validators in the Qt framework. You can set validator, you can use the validate function, you can implement your own validator, but also these are the three validators that are available, and you can also implement your own validator to extend these three validators. List and explain any two regular expression meta characters. So meta characters are these things that we were discussing before. You can pick any two and explain. Then consider the following two regular expressions. Provide any two strings which satisfy the expressions. This one says any number between 3 to 6 digits. Again, this one says a lowercase or an uppercase character, alphabetic character. So here you provide only one. You don't do A, B, C. That's wrong. You just do one, like C, and you're done. Okay, because remember, there's no repetition in this one. It's just a square bracket. But if there's repetition like here, then you've got 3 to 6 digits. Okay, let's look at this one. Describe a scenario that motivates the need for a user to define defined subclass of Q validator. So when it comes to validators, we said there are 3 validators available. This one is used for number integer validation, like range validation. Same applies here, and this one is used for regular validation. But what if you want your validation exceeds these 3? Like you want a validator that can check for a palindrome, a string that looks the same reversed. It means you cannot use any of these 3. So when your validation requirements exceed numerical range validation or validation provided by regular expressions, then you need your own validator. You can then subclass. So it's only when validation requirements exceed what those 3 validators can do for you. Explain the meaning of the following regular expression meta characters. This means non-digit. This means optional. Write a regular expression that allows a string to contain 7 to 8 digits where the first is not 0. So we want 7 to 8 digits where the first is not 0. Now, the temptation that I've seen with most of you is to go not 0 and then, or maybe then just go and then digits. But here, you now go 7 to 8, right? So you are going, well, it's now 6 to 7, right? Because the first one has been kept at 4. But this is where the danger is when you say not 0, because not 0 means anything that is not a 0. It can be A, B, C, or D. So what you want to do in this case is to actually go a number between 1 to 9, because these are the only digits you can ever match. Then you can go plus any digit. So here you can go \D, or you can go 0 to 9. It's all the same. And then you can go 6 to 7 here, and then that's it. Although here you can optionally just use \D as well. In or outside square brackets, that will also do. Okay, so that is your regular expression there. Not this one, not this one. This one is wrong. Describe which character streams will be accepted by the following regular expression. Now, the word here is describe, not give an example. Can you describe? So describing is not interpretation of the regular expression. You're describing the kind of text that we are mentioning here. So what we have here, we've got exactly one uppercase character. In this instance, this curly bracket here is redundant because with or without it, the first square bracket will match one character anyway, right? So this regular expression is equivalent of just going A to Z like that, and then just going \D plus. So how would you describe text that you can match here? So you can say one or more digits preceded or prefixed with an uppercase alphabetic character. Now you can see the way I'm saying it is not the same order that it's there, because the tendency is to say one uppercase character followed by one or more digits. You can also do that, one uppercase character followed by one or more digits, or you can simply say one or more digits prefixed with an uppercase character. That is still the same thing, right? Because you're just describing, not interpreting. So that will also do. What difference would it make if regular expression in 3.1 were replaced with the following? Now, what is the main difference here? So the main difference is the star, because here we said one or more digits. Here we are saying 0 or more digits. So you can, if you are lazy, you can say on uppercase character followed by 0 or more digits. But the question is, what difference would it make? The main difference is that the digits are now optional because 0 digits are allowed, which means if I just go with A in this case, it's correct. But in this case, it's wrong because there has to be at least one digit. So in 3.2, the digits become optional. Okay. Write a regular expression that could be used to check for product codes that are made up of the following two parts. Okay, let's go with it. It begins with 5 to 7 alphanumeric characters, digits, underscores. This is just your underscore W, right? That's, I mean, your W meta character, that's alphanumeric for you, right? And it does include underscores. A final character after the previous 5 to 7, which means it's actually 6 to 8, should be a lowercase alphabetic character or a digit. So that makes your life easy because all you're doing is I've got this, right? Repeated 5 to 7. And then I have a lowercase character or a digit. There you go. Exactly as it is. Another replacement that you can also do here is to go A to Z, 0 to 9 underscore. And you put this in a square bracket. It's also the same thing here with your underscore W. Yeah, that's it. Explain the meaning of the following regular expression: meta characters, \S, 0 or more. Consider the following regular expressions. Describe what strings will be accepted by each of them, not uppercase character A. And there's only one, remember. And this one says A dot plus Z, lowercase. So we are starting, this one says describe, again, not give an example. So here we are saying any character that is not, any non-uppercase character will do. And here we are now saying we start with an A followed by one or more any characters and end with lowercase z. So you can say any word or any text that starts with an uppercase A and ends with a lowercase z. It's uppercase z rather. Yeah, this is uppercase z. So any text that starts with any three, see, there are so many ways you can say this, because your word must be at least 3 characters, right? Because you've got this, which is required, this, which is required, and at least one, any character in between. So you can say any word at least 3 characters long that starts with an uppercase A and ends with an uppercase Z. All right. Qt provides various ways of validating input. Okay, why would you want to create your own custom subclass of validator? So based on this question, it makes me think that what they really wanted on the other question were the 3 validators that are available for validating input, which is the qint validator, double validator, and the q regular expression validator, because it seems like they are associating ways of validating with the type of validator, according to this question. So I'm leaning towards this here as an answer for this question instead of that. That's just my thinking based on this question that we are seeing here. Why would you want to create your own custom subclass of Q validator? Then you can say, yeah, when the requirements of validation extend beyond what the qint validator, double validator, or Q regular expression validator can do. Okay, given the subclass of Q validator below, write code for the validate function so that it will use the regular expression passed to the constructor to determine if the text passed is right. Let's go with it. Valid, right? The text passed meets the requirements of the regular expression exactly, or most valid. The text passed contains text that can be matched by the regular expression, or not valid, the text passed does not contain any text that meets the requirements of the regular expression. So these 3 requirements that you see here are exactly these 3 outputs that we talked about somewhere before. I don't know when I talked about that. I remember doing it. I don't know which slide it was. Where we said, if you use the validate function, you're going to have 3 outputs. Is it acceptable? Is it intermediate? Is it invalid? These are the 3 return types of the validate function. And that is what you're required to do in this question. So what you're actually doing here is implementing the validate function. You are using, inside your validate function, you are using a regular expression. So this is not something you really want to do, because subclassing a Q validator, I mean, creating your own validator and then going ahead and using regular expression simply means you must have used the Q regular expression validator then, because it does that. But for the purposes of this question, they just use it like this. And there are 2 things that you're then required to do inside this function. Number 1, create your validator, right? Which means you're going to use a Q regular expression validator, and then call the validate function of your Q regular expression validator, because the validate function of your Q regular expression validator returns these 3 things for you already, which means you don't really have to do anything. So all you have to do is make an instance of your Q regular expression validator using this regular expression and this position here. I think they are missing the name of the variable here. Normally it's just pos here for the position or for the index. And once you make an instance of your Q regular expression validator, all you then have to do is call the validate function of your Q regular expression validator. So in your function, I was trying not to do the solution here because it's in the handout. But anyway, you're going Q regular expression validator. Your validator expects a regular expression, which is REQ there. Sorry, let's go V, and you give it your regular expression, this one here. Then you simply return V dot validate. Then you validate your string and you give it the position. That is, these are the two lines of code you need in the validate function. So it was very easy to implement if you just remember to use the QRegular expression validator. And the validate function will then return three values. It will return qt dot acceptable, or qt intermediate, or it will return, this is an enum, that's why it's going qt dot invalid. So these are the three outputs that it returns for you. And each of these three here map to the three requirements that are there. But the validate function returns that for you. And this is an enum, and these are the values that you then, no, it's not qt dot, it's q validator dot, sorry for that. It should be q validator dot acceptable dot intermediate dot invalid. I think it should be like that. I'm quite sure. Regular expressions will be used to determine that correct data will be entered before it is included in the list of productions. So this is a follow-up to a previous question, obviously 1.5 or 321. So this was within a given context. Indicate what sort of text will be accepted by the following regular expressions. Minimal marks will be awarded for simply describing the regular expression components. Okay, indicate what sort of text will be accepted, and the minimal marks will be awarded for simply describing the regular expression components. So if you just go lowercase or uppercase character, 0 or more, any number, 1 or more digits, and any. So if you just interpret this, I think this goes along with what I was saying before. You are not just interpreting what this is, you are describing the text that will be matched, right? So this matches any alphabetic character, 0 or more. Then you need at least 1 digit, and then 0 or more alphabetic characters. So I've just said it as it is. But how would you describe such text, right? So you can then say at least 1 digit prefixed by an alphabetic character and postfixed by prefixed by any alphabetic characters and postfixed by any alphabetic characters. Something like that, right? You can rephrase that the way you want. Then this one is interesting because we have at least a digit. Then this whole bracket here is optional because of that question mark that we see there, right? Now, what is optional? They put a dot here. I want to believe that what they really wanted was \dot here. I want to believe they wanted the backslash. Come on, click my slide. There. I want to believe that is what they wanted, because then you can say any digit with an optional decimal one, with an optional 1 decimal place. Because then the dot means this can be 346.5, 1 or more digits followed by a dot and a number. But if we leave this with, if we just leave it, if we just leave it as this, and then we say a dot and then a digit and then optional, that means a digit followed by any character and then digits, which then doesn't make much sense, because this means at least 1 digit optionally followed by any character and a digit, which doesn't really make sense. I would go with one or more digits, then optional one decimal placed digit. Okay. So that is how I would approach that question. I think there was a mistake there. And the last question, I mean, there are so many questions you can do on regular expressions. You just have to keep on practicing. And if you find any question that you think is a bit challenging or tricky, you can bring that on during our live classes and you can look at it, right? A vehicle identification number is comprised of 17 characters made up of digits in the range of 0 to 9 and uppercase characters in the range of A to Z. Now, the requirement is that the first 9 characters are a combination of digits and letters representing the country where the vehicle was manufactured. So in other words, you can just go ahead and say, so our first 9 characters are going to be digits and numbers. And these are our first 9 characters, right? Sorry. Right. So this part is done. Okay. The 10th to the 17th characters, the remaining. The first is a digit excluding 0 or a letter excluding Z, representing the year of manufacture. So we then want one character here, which is 1 to 9 because it's not 0, or any letter excluding Z. So for the next 17, remember, from this point forward, we want 17 characters here. No, we want the 10th to the 17th, not 17. So this is from the 10th to the 17th character. So that's 7 characters, right? Plus that's 8 characters plus the first 9, which makes them 17. So here, from this point forward, we want 8 characters, right? 10th to the 17th, okay. And 1 is catered for already, okay? The second one is a digit or letter representing the plant where the vehicle was manufactured. A digit or a letter. So you can go with \D or you can go with 0 to 9, but it's any letter or a digit. That is the second one. Now we are left with 6. The remaining characters are all digits representing the production number. You can go with a \D or you can go with a 0 to 9. And the remaining ones are now 6 characters. So this then becomes your regular expression, which means this goes 9, 10, 11, then 12, 13, 14, 15, 16. Why do I have 16 characters here? 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, that's it. So that is how you will formulate such a regular expression. You just need to practice. There are so many examples, that you can find in past exam papers that I want you guys to go and try and find and try and do. There are others that are more interesting than others. I think one of the most interesting examples that I would have wanted to do was the one that says the year should be between, I think it says between 2000 and 2019, something like that. And then they say, so write a regular expression that can validate this year. And obviously the answer is not 2000 to 2019. This just means it's a 2 or a 0 or a 0 or a 0 or a 0 to 2 or a 0 or a 1 or a 9. You have to validate each index. It's an interesting one to solve. You have to use brackets and or and all of that. So it's all for you to go and practice, and then during our live classes we can catch up and discuss more on regular expressions. So if you're not on the platform, please feel free to join us on ivtutor.com, where we can break these things down and help each other out. Otherwise, that is it for this video. I'll see you guys in the next one. Cheers.